Hello, AP Chemistry students. This is a video on conversion factors. And conversion factors are very important in AP Chemistry. We're going to use those quite often, and we need to be very comfortable at jumping in and out of different units. So what we're going to be using today, or looking at today, is we're going to be looking at what's called dimensional analysis. Dimensional analysis, very important, allows us to use units, units that are going to be after some sort of measurement. Unit might be grams or milliliters, unit might be inches or centimeters or something like that, or it might be moles, grams, things like that, to guide us to the solution of a problem. So we're going to use these units. And what we're going to do is we're going to create what are called conversion factors. And these conversion factors are an equality used to convert from one unit to another. So what we have here is a conversion factor of 1 inch is equal to 2.54 centimeters. Now we could turn these into two fractions that are going to be equal to each other. We can have 1 inch over 2.54 centimeters, and this is going to be equal to 2.54 centimeters over 1 inch. These are both considered a conversion factor to convert from one unit to another, really depending upon how we start this all out. And we did this when we did moles and stoichiometry in regular chemistry, and we're going to do it a lot in AP chemistry. And so let's take a look at our first example here and see how this conversion factor works out here. Move some of this stuff out of the way. Okay, so they give us the information of how many centimeters in the measurement of 55 inches. So 55 inches is our known quantity. So I'm going to just put 55 centimeters just like this. I'm going to create a little picket fence, and then I'm going to look at what I'm trying to find. And in this problem, I'm trying to find centimeters. I think I made a little mistake here. Let me erase here because I wrote centimeters here, but really I was in inches. And I'm trying to find centimeters. So what I'm going to do is I'm going to choose the conversion factor that has centimeters on the top, and that would be this conversion factor here. So we're going to put 2.54 centimeters there, and then on the bottom down here, we're going to put 1 inch. Now, the way we use dimensional analysis to make sure that we're getting to the right place is we always want to make sure that our units cancel out to the correct unit at the end. So because we have the unit of inches on the top and on the bottom is the numerator and the denominator, our units did cancel out and we were left with a unit of centimeters, which is what we were after in the first place. So we're just going to multiply these two values together. So it's going to be 139.7. And now because these are conversion factors, these guys are conversion factors, there's a conversion factor there and there, we don't use those for sig figs, so we are going to use sig figs based off of 2 sig figs there. So we're going to round it off to 2 sig figs. So 139.7 rounded off to 2 sig figs, we can call it 1.4 times 10 to the second centimeter as our answer. 140 would also suffice. And that's how we do an easy conversion factor. Let's jump into something a little bit more challenging. Something like this, which we could do multiple conversions. And again, these types of problems, we can just Google the answer if we wanted to. It'd be really easy. If I wanted to convert 515 centimeters, or looks like it's meters per second, into miles per hour, I could just plug that into Google and it would just spit an answer out and it would be fantastic. And why even worry about how to do these? Well, the reason we worry about how to do these is on the AP test, there's no Google. And on tests in AP chemistry, there's also no Google. So we can't just Google these answers. We have to know how to do these guys. So let's take a look at how we do multiple conversion factors. Again, our known quantity is 515 meters, and I'm just going to put it really long like that, per second, and we ultimately want to get to miles per hour. So I'm going to kind of convert things a step at a time here. Now where to find conversion factors? There's a couple places to find the conversion factors. The last page of your book, on the inside back cover, there's a bunch of conversion factors, and I've also given you a link, and I'll show you what it looks like, to assignment number 2, common unit conversions, and you'll see there's just 6 pages of conversion factors. You, of course, won't have to memorize all of these conversion factors, but there's some really good, helpful conversion factors on that link. So we can look in either place for these types of conversion factors. And so let's go back to our problem here. And so I'm gonna convert first my time measurements, and second I'm gonna convert my distance measurements. So we're starting with seconds, and we want to get to hours. And so what I'm going to do is I'm going to create some conversion factors. So I have 1 hour is going to be equal to 60 minutes. Obviously, 1 minute is equal to 60 seconds. And so I'm going to use these as conversion factors to go one place to another. So because I have seconds as my denominator, I want seconds as my numerator up here so they can cancel them out. And so it's going to be 60 seconds is equal to 1 minute. And then obviously I'm going to put 60 minutes on top is equal to 1 hour. And now if I look through here and I cancel some things out, seconds is going to cancel with seconds, minutes is going to cancel with minutes, and I'm left with a unit of hours, which is what I'm after on the bottom. Okay, so that's how we're going to get through that. Now let's go and take a look at our meters measurements. And again, we want to take meters and we want to jump it into miles. Okay, so looking in the back of our book, there's a couple conversion factors we can use. We can use 1 kilometer, which is equal to 1,000 meters. And the reason why I use that one is because also in the back of the book, I have 1 kilometer is equal to 0.62137 miles. So what I can do now is, because I'm starting with a unit up here of meters, I want to cancel that meters out. So what I'm going to do is I'm going to plug meters in on the bottom using this conversion factor, and then I'm going to use the 1 kilometer conversion factor, and then I'm going to use this other one here, and I'm going to put 1 kilometer on the bottom and 0.62137 miles on the top. And now let's go through and cancel some of these guys out. So meters on the top is a numerator, meters on the bottom is going to cancel, kilometers is a numerator, kilometers is a denominator, and so we're left with looks like a unit. Everything that's left is going to be miles as our numerator over hour as our denominator. And so what we're going to do is we're going to multiply straight across the top 515 multiplied by 60 multiplied by 60 multiplied by 0.62137, and we're going to divide by 1,000 and see what we come up with. Okay, and I come up with 115.2.0, and which is too many sig figs. And so we'll look back and we have 3 sig figs there. So let's round this up to 3 sig figs, put it in scientific notation. We'll go 1.15 times 10 to the third miles per hour. And that's how we do that conversion. Now this is, again, we could have just looked this up on Google. Really important to be familiar with how to jump in and out of conversions in AP Chemistry. Let's talk about a couple of other things here. We have temperature conversions up next. Temperature conversions we covered in general chemistry, and we're going to cover them again. It's really important when we get into gas laws. And so here's our main formula for temperature conversions. We have degrees Celsius plus 273, which allows us to get into Kelvin temperature. And notice there is no degree sign on the Kelvin. So let's just show you how to do a couple of these problems super fast. So essentially, we're just going to plug into this and solve it algebraically. So the first one, it says convert 30 degrees Celsius to Kelvin. So we're just going to plug in 30 degrees Celsius to that formula, plus 273 equals 303 Kelvin. 50 Kelvin, so 0 degrees, or we have degrees Celsius plus 273 equals 250 Kelvin, and we're not going to subtract 250, we're going to subtract 273 from both sides, minus 273, just like that. And so we're going to get degrees Celsius equals minus 23, which makes a little bit more sense. There we go. Last type of calculation we're going to be talking about today is volume and density calculations. We can do volume calculations. Of course, probably one of the most common liquid volume calculations we'll be looking at is the conversion factor of 1 liter is equal to 1,000 milliliters. We use this one quite often. Something this will definitely be memorized, especially for things like molarity calculations. But let's take a look at the density formula here. So density of a substance is equal to the mass of the substance, typically measured in grams, over the volume of the substance typically measured in milliliters, unless we're talking about gases, which then it'll be grams per liter. So what we're going to do is we're going to take a look at this problem that kind of incorporates a couple different things here. Simple conversion plus using the density formula. So it says, what is the mass in grams of 1 gallon of water if the density of water is 1 gram per milliliter? This is pure water. Pure water can have a density of 1 gram per milliliter, which is really helpful in calculations because it allows us to easily convert from again, it allows us to easily convert from density into milliliters. So if we have 1 gram of pure water, it's going to tell us that's 1 milliliter of pure water. It's very helpful. Okay, so let's take a look at this problem here. So in using the density formula, density equals mass divided by volume, it does tell us that we do have a density of 1.0 grams per milliliter. And ultimately, what we're trying to find in this problem is we're trying to find mass. We're trying to find mass. So if we can find the volume, we can plug volume in here and easily solve this for mass. And the problem is they gave us a volume in the wrong unit. They gave us 1 gallon of water. So what we're going to do is we're going to use 1 gallon of water, and we want to convert this guy somehow into milliliters of water. So we're going to look at the back of our book and look for a conversion factor, or we can look on that conversion sheet that I gave you as well. Okay, so the conversion factor I see in the back of the book is they're giving me a conversion of 1 gallon is equal to 3.7854 liters, which is helpful because we can always do 1 liter is equal to 1,000 milliliters. And so it's just a double conversion. And so let's take the first one there and put 1 gallon on the bottom and 3.7854 liters as the numerator, 1 liter on the bottom, and 1,000 milliliters on the top. Double check those units. Gallons are going to cancel with gallons, liters with liters. We're left with an answer in milliliters. So let's run that through our calculator here real quick. And I get 37854 milliliters as our unit. I'm not going to round yet until I get to the very end. And so let's go ahead and plug this in over here. And so we're going to plug that in as 3785.4 milliliters. And we're going to solve it for density by multiplying both sides by this value. Obviously, when we're multiplying by 1.0, it's going to be the same. So mass is going to equal 3785.4 grams, which way too many sig figs there. Let's go to 2 sig figs. Let's call this 3.8 times 10 to the third grams. And there's our final answer. Of course, there's going to be a worksheet that goes along with this, and there's going to be an online quiz.